Hello everyone. Today I would like to talk about the newest version of Demetra Plus software and especially of enhanced feature for production of seasonally adjusted data. So after an introduction, I will go over a production process with GDemetra Plus using a graphical user interface, then a process fully in R, and then the newest solution combining R tools and the graphical user interface in order to optimize this process. So let's dive in. The motivation of this presentation is that the production of seasonally adjusted data often requires, on one side, maximally automating operation, but also on the other side, a framework providing a bespoke visual feedback, diagnostic, plots, and allowing efficient manual interventions. And so these properties can be hard to bring together in one process. So the goal of this presentation is to indeed introduce our tools related to GDemetra Plus, which are designed to keep the benefits of using a graphical user interface for user intervention, and on the other side, automating a number of otherwise cumbersome operations, like, for example, customizing specification series by series on a very large dataset. So first, a brief overview of GDemetra Plus software. So it's an open source software for time series analysis, which is developed in the framework of the Eurostat network called SAS, and it's developed by National Bank of Belgium with the support of Bundesbank and INSEE. So it provides algorithms for seasonal adjustment, including extension for intra-monthly data, trend estimation, benchmarking and temporal disaggregation, and nowcasting and revision analysis. And so these algorithms implemented in Java, hence the GDemetra, can be accessed with a graphical user interface or directly through a suite of R packages, the RGDverse. So now let's focus on the features for production of seasonally adjusted data. Here are the seasonal adjustment algorithms available in GDemetra Plus version 3. So you see you have the two historic ones at the core of GDemetra, X13 ARIMA and Chromoseeds, and some new algorithms. They can be accessed with the graphical user interface and a dedicated R package, and for the time being, only X13 ARIMA and Chromoseeds have production features, which is the ability to do large-scale estimation with the graphical user interface and export this large output. So all these algorithms for low-frequency data work with the periodicities 12, 6, 4, 3, and 2. So now let's see a production process with GDemetra using the graphical user interface. So maybe first briefly a look into this graphical user interface. So you see it's a visual feedback, very rich and designed for quick manual intervention. Here in the middle you have the diagnostics, the charts, and you can modify the specification quickly on any series using this specification box here. And on the left side, you have specification boxes which can be cloned and customized for a large dataset. So when you use this graphical user interface, this will require setting up a workspace, which is a specific data structure composed of a collection of XML files. This file contains raw data, parameter, diagnostics, and allow to perform the estimation, generate output, and display the results. Just note that in GDemetra Plus, results are never saved. Just data and estimation parameters and results are refreshed every time. Data in GDemetra can also be refreshed applying a selected revision policies, which is a constraint re-estimation recommended in and useful in infra-annual production. So month to month, you don't want maybe to re-estimate all your models and features, and you still might want, for example, to re-identify outlier on the last 12 months, and then just re-estimate the coefficients of your ARIMA model, and otherwise keep the rest unchanged. And so as you've seen, graphical user interface is designed for easier manual fine-tuning because it has a very good multi-layer feedback. But the shortcoming is that when you rely on the graphical user interface, it's really mouse click intensive, and you very quickly need tools to automate operation. So the first way to automate operation is to use the module called the cruncher, which also works on workspaces and is compatible with a graphical user interface, and will allow you to update a workspace with a given policy, and it can be launched in SAS or R or whatever. So here would be the code. For example, I target my workspace, define my policy, and launch this function, which belongs to the RJWSA cruncher package, which is on cron, and I will have a whole re-estimation of my workspace and the production of the entire output, series, diagnostics, and parameters. So to this, I can also add a quality report using the JDEC cruncher package. I will be able to extract all parameters and diagnostics, and to put them into a nice table file, which can be in Excel or whatever else, where I can also add a score to see which series have the worst statistical problems, and also add a weighting system, which will allow to show the importance of the series maybe in my dissemination process. And so this allows to do selective editing and to optimize the constrained time I might have to do manual fine-tuning. So a quality report like this would look in Excel like this. I have the values of my tests. Here I have the score of my series, the contribution to the score, so I immediately see what the problems are. And I also have my weights and my weighted score, so I can order according to the worst weighted score and program my manual revisions accordingly. So that was for the graphical user interface, which can be, as you've seen, enhanced with the cruncher. Now let's talk about a production process fully done in R. So the R packages you will need here are all available on GitHub, RGDiverse page, and most of them are not on cron because we have still a Java compatibility issue at this time. So we need, for GDemetra version 3, we need Java 17 or higher, and most cron machines still run on 11, and we hope it will be fixed soon. So you can install them from GitHub or from RUniverse. And in the README files on GitHub, you will find all about installation procedures, of course, and some basic examples. So if I want to do production fully in R, what does it mean? I will use time series object. I will forget the existence of the graphical user interface and the workspace structure. I will still be using, of course, the exact same algorithm written in Java. It's just a matter of access difference. And so, for example, for X13 ARIMA and thrombocytes, I will do the estimation with the packages RGD3X13 and RGD3 thrombocytes, where I will have options to add calendar regressors, external regressors, anything which can be done in the graphical user interface. And also, as with the graphical user interface, I will be able to refresh my data with the given policy. So here are some examples. Maybe on month to month, I want to keep my model fixed and use policy fixed, or I want to re-identify outliers on a given time span, and for this I will use the policy outliers. So I can do all this, and the code will look like this. From the estimation process, I get an R object, which is a list of lists here, SAX13v3, and there I can modify my specs and apply my revision policies, refreshing my spec with the new policy and then apply it on my new data. So production in R looks very complete at this stage, but the shortcomings are that for now, if you have very large data sets, you have to use loops and estimation in R because all is designed to work on one series. And so this will give you an overall much slower estimation than the graphical user interface combined with the cruncher. And so if your data is not readable by the graphical user interface, then you will end up with prints and summaries of your results, which will give you a lower quality visual feedback and less manual fine-tuning possibilities, especially if your analysts are not R users. So of course you could build a shiny app interface, but well, GeoMetra Plus already has a graphical user interface. So how to take the best of the two processes, the flexibility of R and the visual feedback and speed of graphical user interface and cruncher? Well, we have tools to combine the two setups. So here we will be using two packages, RGD3 providers to wrangle our data and RGD3 workspace to optimize our workspaces in R. And these packages will allow us to create, read workspaces, updates link from raw data to workspace, customize specifications on a very large scale, like for example, setting predefined outliers series by series, or assigning predefined set of calendar regressors, merging workspaces by names, as you could do with data tables, so regain some flexibility and still be able to use the graphical user interface. And also this is very useful if you are coming back from an older system, you have old specification, be it in GeoMetra or not, you can rewrite your old specification, for example, old outliers, old parameters in your new GeoMetra Plus version 3 workspaces with these tools. So let's see some examples. So creation and saving of workspaces can be done with RGD3 workspace. Then you would create a virtual workspace, and when you write and save, it will create the workspace, which is the collection of XML files identical to what would have been created with the graphical user interface. You can also add series to workspaces with this kind of function, which will manipulate add SR item, which will manipulate SR items, which means the series, all the parameters and all the metadata, which is around the series, exactly as if you had built this with the graphical user interface. So with a specification and row series, you can build a new SR item and add it to your workspace using only R code. So if you had to do it on a very massive scale, that's where it gets interesting. So do the same with an SR item located in another workspace. You can also replace series in your workspace by an updated version on your series coming from another production process, another workspace. You can, of course, remove the series. You can update the link from your workspace to your data, which is very important. If you move workspaces and data around because you are several people collaborating on this process. So it's a very important features to have. And that is how you will be updating your database. So you can also merge two workspaces. So the use case example of this functionality is, for example, an annual review. You are reviewing the current models you have, and you will compare them to a new estimation. And for this, with the quality report I've shown you before, you can use a score. And for example, decide that where the score is lower, you will use a new estimation, whereas if the new estimation doesn't give a lower anomaly score, you will keep your current estimation. And as you will know, which series has the lower score, you will be able to merge the two workspaces, the current one and the new one, to get a new combined workspace for your next year of seasonal adjustment. You can also customize specifications on a very, very large scale. So for example, if you had your COVID outliers somewhere in another workspace on process, and you want to keep the outliers you've been carefully identifying during COVID in a new process, but on a very large scale, again, which would be impossible just with graphical user interface, mouse and click, you would do this kind of function where you modify your spec and then you save it to another, item and replace this item in your workspace. You can also refresh your workspace directly in R. So you could do it with the cruncher or R once you have a workspace, but in fact, you have the R tools to do it. So that's my last slide here. So this is the whole set of examples I wanted to show you about R tools, which allow you to optimize your workspaces in a way that a maximal number of cumbersome operations are automated. So here I come to my conclusion. So let's say that if you're using the graphical user interface and obviously the cruncher, if you want to produce on large data sets, your assets are that you have a very structured feedback in the interface, which makes manual fine-tuning easier. And the shortcomings is that you have this additional data structure, and you have also display constraints in the graphical user interface. And so the recent improvements consist in creating R tools, which allow to automate operation on workspaces with R functions. So create, for example, graphical user interface readable dynamic workspace if at any time in the process, merge them, customize specification on a large scale, which allows you to handle very large datasets. And so the user can more smoothly now transition from R estimation on TS object to graphical user interface based processes. And so the two paths, do I use graphical user interface or do I use R, are not as separate as they used to be. And in the target version of GeoMetra Plus, the additional algorithm I've shown you at the beginning, X12 plus, STL plus, and structural time series STS will also be usable in the production framework, meaning they will have workspaces which can be estimated by the cruncher, and it will be possible to do large production on large dataset with this algorithm as well. So just some useful links. Here, if you want to get the software, it's on GitHub, packages as well. You have GeoMetra Plus documentation, a blog, and our contacts on GitHub. And with this, I thank you for your attention and say goodbye from Paris.